Am I audible to you? Good evening. Okay. Okay. Let's start this session. This is the third tutorial session for the lecture Smart Grid Basics to Advanced Technologies. First of all, I will introduce myself. I'm Mohammed Owais Khan, Prime Minister Research Fellow in the Electrical Engineering Department, Aligarh Muslim University. So, in this session, we will be talking about the recap of the last week. You know, the third lecture, the third week lectures. Okay. So, first of all, the topic here is what we are going to discuss here is first is storages actually. What's their purpose and how we can operate them and what's their advantages, why there is a need that we should use storage. So there must be some advantages through them, that's why we are using it. So we will discuss in detail all three aspects and also we will see what is the history of these energy storage systems and what is the current scenario of the deployment of storage devices in India or anywhere else. Okay, so we will see first of all this. So I think this is my writing is quite clear to you. I hope. So now what we are going to discuss here first is the purpose of storages, storage device. What's their purpose? Why are we using it? So one of the most important thing is that actually in the last two lectures I have been talking about the integration of the renewable energy sources in detail and I have talked about mainly to wind and solar. Okay. Now what happens here is that as you know that solar is generally in a day it is only available during daytime. Okay. It is not available 24 into 7. That's why another energy source which is wind, it is also dependent upon the weather condition. If there is wind, then the wind energy will be produced. Now, one of the most important thing here is that these I have already told in the last lecture that these cannot be used as base load power plant. What are the base load type power plant? Those satisfy the base load or load demand means that they work 24 into 7. But due to the dependence of on the weather conditions, they have very intermittent type of energy production. Means sometimes the energy will be available from them, and some instant the energy will not be there. So what we do here is that the researchers, what they have done, they have uh, they have stored the energy produced into the uh, storage devices. Okay, so what it will do here is this, that the storage devices, when they store energy, the energy can be pulled back from here at those times when the base load power plant are not unable to satisfy the demand. So extra energy can be used from here. So uh, that's why there is a very need of that's why there is need of storage devices. This is one of the most important reason. That's why nowadays storage devices are in trend. Another, I have already said here in this, due to the increase in penetration of renewable energy sources, renewable energy sources, or we can also say them variable renewable energy, VRE. We can also call them. Okay. Now, this is another reason. Another reason is this. Now, why are we using these renewable energies? To Due to decarbonization. This is also one of the main reason, decarbonization of the economy. Okay, this is another reason. What these storage devices do, they store the excess of renewable energy and renewable energy power generated. So what they do here is that they store the excess of power which is generated by renewable energy, and it also helps in satisfying the peak demand. When the base load power plants cannot satisfy the load demand. Okay. Actually, these are easily, they can be easily installed in comparison to the low conventional fossil fuels like nuclear energy or thermal power plant. So that's why they are also used as solution to increase the system flexibility. Now, one of the major important thing is that these can be installed nearby load centers. So what it does here is that, because generally the nuclear power plant or thermal power plant or hydro, they are generally located very far away from the human population. But these storage devices can be installed nearby load center, which leads to reduced power loss, in transmission of the power. So this is the a short, you can say, the why the storage devices has nowadays their trend has been increasing. These are some of the reasons. First is due to the penetration of renewable energy. Second is due to the decarbonization. And another thing is that they store the, what they do here is that they store excess power, and they also help in satisfying the peak demand when the base demand load cannot be satisfied by the other conventional sources, and they also help in increasing the system flexibility. Okay. Now, coming towards another thing here is the history of these storage devices, which we call as energy storage system, ESS. It is known as energy storage system. Okay. So first of all, first type in 1839. In 1839, first fuel cell was developed by William Robert Groves, known as Sir William Robert Groves. And this fuel cell is made up of hydrogen and oxygen, and it is in the presence of an electrolyte. In the presence of an electrolyte, it produces what? Electricity and water. This is the first fuel cell which has been, in 1839. After that, in 1859, a lead acid battery type of storage system is developed by a French physicist. This is developed by French physicist known as Gaston Planté. It actually, this is the first rechargeable battery developed after 20 years of fuel cell. Okay, and it is based on the chemistry of, we all know, the lead and acid. Okay. Then after that, another historical point comes in 1883, in which a flywheel based storage, means base storage, energy storage, has been developed by a scientist who is known as John A. Owais, in which flywheel has been used to develop the energy, and the energy has been stored in the battery. And in this flywheel-based energy storage, generally in initial days, used in military operations or applications. Now, another such development took place in 1899, which is nickel cadmium battery. हाँ नाउ ये डेवलप करा गया था बाय अ स्वीडिश स्वीडिश साइंटिस्ट whose name is Waldemar Yoગner। इसने क्या इन्वेंट करा था? अ बैटरी निकिल और कैडमियम के इलेक्ट्रोड्स को निकिल एंड कैडमियम के इलेक्ट्रोड्स को पोटेशियम हाइड्रोक्साइड सॉल्यूशन में पोटेशियम हाइड्रोक्साइड पोटेशियम हाइड्रो ऑक्साइड के सॉल्यूशन में रखा था। तो पोटेशियम हाइड्रोक्साइड क्या हुआ इसका? इलेक्ट्रोलाइट। ओके, नाउ आफ्टर दिस another you know invention took place in 1907 in this pumped hydro based energy storage developed by energy storage developed in Switzerland। This is been developed at it has been first used in Switzerland, where there is a pumped storage facility, where there is a pumped storage facility which is known as Engg Wahine. Okay. Now after this, in 1982, a supercapacitor base, which is very recent in comparison to other, a supercapacitor based energy storage has been developed, and it has been developed by a research institute known as Pinnacle. Now, this is also used in the military applications in earlier days when it was developed, and it has very low resistance, so it helps in storage of the electricity. There is another which I think is in 1969 actually. Before that, this is after, this is before that. In 1969, a superconducting based magnetic energy storage is developed, and it has been developed by Farrier, a research scientist. Okay, so and in latest 2007, a paper-based battery has been developed. Paper battery. It has been developed by 3 scientists from Rensselaer Polytechnic Institute in New York. And they also generated a concept known as paper batteries, which can be used in a low demand energy applications. So this is a somewhat history of the flywheel of the storage devices, starting from 1839 fuel cell developed. Then after that, lead acid battery has been developed, which we generally use nowadays in our inverters, which are home based. In 83, flywheel storage developed, and then coming on a pumped hydro based energy storage. This is the most used type of storage. You must have studied detail in your graduation. And now coming toward the classification of an energy storage. Now they are classified energy storage classification. Okay, how the energy has been developed and stored in any energy storage devices. First one is thermal, means it has it says that thermal combustion or anything has been done to create to generate the energy, and that energy has been stored in the energy storage system. Another is the elect electrochemical electro electrochemical based energy sources. Electrochemical based energy sources. Another here is this a chemical based energy storage. What it does here in this in this the chemical reactions has been done to generate the energy, and that and generated energy has been storage in the has been stored in energy storage. Those type of energy storage are known as chemical based energy storage. Another is the mechanical based energy storage. In this, a mechanical part, the energy is generated by moving something like, flywheel has been moved, like pumped hydro, or gravity is used to generate the energy, and that generated energy has been stored in those energy storage. So those type of energy storage will be known as mechanical based energy storage. Okay, so these are some of the classification of the energy storages. Just a second. Okay. Now, there is another type of energy storage which generally has been used are hybrid energy storage system. Actually, they are a mix of ESS in which two types of categories of energy storages has been merged. One with a high energy density storage system, and another one are high power storage system. So if we merge both these types of energy storages, then we will get the hybrid type of energy storage. And for example, there has been in 2016 in United States a 1.2 megawatt supercapacitor and battery based hybrid energy source has been developed. And in another case in Germany 2018, 11.5 megawatt lithium ion and sodium sulfur batteries has been developed. So these has been developed. Okay. In 2021 in Australia, Monash University. You must have heard the name. Monash University, 1 megawatt vanadium and lithium ion batteries based hybrid system have been developed for achieving net zero target. I already told you about that these batteries also helpful in the decarbonization. Okay, so this is the history of a battery energy storage system. Now, why do we need any energy storage? Why do we need any ESS? Why? So one of the main thing is this. It helps in the storage, of course, which is I have already said. Now, after storing the energy, it also helps in the frequency regulation. Frequency regulation. Okay. It also help in you know congestion relief. Congestion relief of transmission and distribution network. How? Because sometimes in the distribution night when they I have explained this whenever there is any peak demand or any abrupt need of energy power demand arises, then these ESS can be switched on to help that you know to satisfy that energy demand. Okay, it also helps in reduced reliance on fossil fuel, sorry, on diesel generator. Like for example, if you have a house, okay, and you have solar energy installed over it, and at around in 8 p.m. after sunset, okay, after sunset, what happens here is that after sunset there is a power blackout. Power blackout. So there are two options you can go. Either you can go for a diesel generator based energy demand, or also you can say that, or also you can use the energy generated by the solar cell in the day, which is stored in the energy storages, can also be used to satisfy the demand during the power blackout. तो ये होता है कि अगर स्टोरेजेस होते हैं हमारे पास, तो हम सोलर एनर्जी को स्टोरेजेस में स्टोर करने के बाद उसको एट एनी पॉइंट ऑफ टाइम व्हेन देयर इज पावर आउटेज वी कैन यूज इट इंस्टेड ऑफ यूजिंग डीजल जनरेटर. Okay, these ESS are also used in energy shifting. You've heard a very popular term nowadays, that energy transition from a fossil fuel base to a renewable energy base. So how can we transform from a fossil fuel to renewable? It can always transform by using the energy storages. And I have already explained that why energy storage is very important, because if we store the energy generated during daytime by solar or we can use it at any point of time whenever there is an outage. So in this scenario, these ESS also helps. Okay, now after that, they also work as a capacity reserve. Capacity reserve, and they also can be discharged during at the rate peak hours. During peak hours. Okay. Congestion relief, I have already told about this. Now, what happens here is this. These are all points which tells you about why do we need energy storage nowadays. Now, coming towards the thing. So, first of all, the largest solar power based solar based battery system is installed in the Florida by Florida Power Company, and it is around 409 megawatt capacity, and it has been and 132 ESS are there across 40 acres. And due to the installation of the ESS, what happens here is this, around this much ton of carbon dioxide has been eliminated. So you can see that it also helps in the achieving our net zero or in decarbonization of economy. आप लोगों ने काफी सुना होगा आजकल there has been talks about decarbonization of this thing. So these all battery energy system will help in achieving that. Now coming towards the deployment step, how much is storage deployed across the world? We will talk about it. So storage deployment statistics are in India, electrochemical based, or we can say that for thermal storage has been deployed around 0.2 gigawatt, and pumped hydrogen based storage is around 6.8. So total here is 7 gigawatt. This is in gigawatt. Similarly, next in this list is China. China has a total of 32.1 gigawatt. Yeah, and 32.1, yes. And pump out of which pumped has 32 gigawatt, and 0.1 is thermal, and 0.1 is electrochemical. Electrochemical is 0.1. Next in this list is Japan. Japan has it is around 28.5 gigawatt storage deployment, and then comes United States, which has 24.8. So as you can see there, these are some of the top countries which have deployed the storage. India is far behind it. That's why you can see in India the government is pushing toward the storage deployment. Okay. Now, so this is all about how the storage can be used, why the storage is, why do we need ESS, and this is about the classification of storages. Okay. After this, we have talked about history of storages. What is the history from 1839 to 1859, and then 1883 flywheel base, 1899 nickel cadmium. Okay. Now we will talk about the another thing, which is what are the different terminologies over here. So different terminologies which has been used in the battery architecture. So first one is energy density. What does it tell us about? It tells about the amount of energy that can be stored in a storage device, we can see, that has a set volume and mass. For a given volume and mass, how much energy can be stored in any device? It is known as a energy density. Now, if we on the similar lines, we can say that amount of power which can be stored in the given battery. It is also known as power density. Now, another thing is the cycle life. You must have heard what is a cycle life. Actually, it is described as for any energy storage. For any energy storage, it is described as a function of depth of discharge and it is also known as number of cycles that ESS can charge or discharge over its life. For example, let's say there is a battery which has 100 cycles. So, what happens here is this, after 1000 cycles, the power output will reduce. But up to that 1000 cycles, the power output will be significant. Next term here is this response time. Response time. What is the response time? It is actually decided. It is actually described as a time for an ESS which goes from 0 to 100% of rated power. And if we divide this, the rated power, if we divide the rated power with the response time, what we will get here is ramp rate. Okay, this is like this. Okay, these are some of the terms which we use when we calculate anything about batteries or things. Now, coming towards the classification, I have already classified batteries. How batteries has been classified? First is the mechanical classification. Okay, mechanical classification. What are those? These are pumped hydro, compressed air, and flywheel. And others are electrochemical. Why these are known as electrochemical based energy system? Because the energy which is produced in these energy which are stored in these type of batteries is being produced by the electrochemical reaction, like lithium ion. Another is lead acid, vanadium based. Another is sodium sulfur. Okay, these are electrochemical based energy sources. Others, there is another classification which is a chemical based, means the energy generated due to only the chemical reaction, like fuel cell, biofuel, Okay. Another classification is electromagnetic, where energy is generated due to the electromagnetic phenomena. These are supercapacitor, magnetic based energy storage system. Another is superconducting. Okay. Now, another type of storage comes out which is known as thermal, in which the energy which is stored in this type of energy storages, they are generally produced by the thermal generation, like thermochemical, you know. Another here is this hybrid. What is hybrid energy storage? If we combine any two of these other storages and produce an energy system, this is known as a hybrid energy system, like battery plus flywheel. Another here is battery plus fuel cell plus supercapacitor. So this is a hybrid type of energy storage system. Okay. There will be another, like, battery plus others you can use. Okay. Now, coming towards the different battery energy densities. Like I have just described what is energy density. So lithium ion, there is NaS. Another is vanadium flow base. Another is nickel, cadmium, and lead acid, which we use in our inverters. So the energy density of these, it has been measured in kilowatt per kilogram. So for lithium ion, it varies from 150 to 200. For this 125 to 150, from flow from 60 to 80, from this is 40 to 60. For lead acid, it is 30 to 50. You can see that the lithium ion has a higher energy density. That's why lithium ion will give higher energy for every kilogram. What it signifies? It signifies that for every kilogram, it will give this much amount of energy in comparison to other, like lead acid will give 30 to 50. So you can see that the smaller the size will become, the lithium ion will give more energy in comparison to others. That's why these type of energy has been used in mobiles where the size is a very much constrained. And now is efficiency. What is the efficiency of this? This is, so it will give 95% efficiency. Its efficiency of second varies from 75 to 85. For vanadium flow, it varies from 70 to 75. And nickel cadmium, it varies from 60 to 80. And for lead acid, it varies from 60 to 70. So clearly we can see that the lithium ion has a higher energy density. It will give more energy per kilogram, but it also have a higher efficiency. Now, coming toward the lifespan. What is the lifespan of these batteries? Is there any change in them or not? So, for a lithium ion, the lifespan is around 10 to 15 years. It is in years. Okay. For this, the NAS for 10 to 12. For vanadium flow is 7 to 11 years. Nickel cadmium also 10 to 15. And lead acid it is 3 to 6 years. So you can clearly see that lithium ion and nickel cadmium has almost similar type of lifespan, but the difference in efficiency and the energy density is quite considerable. And also you can see, you can relate it from the lead acid, which we use in household inverters. And you can see from here that in a household inverter, we have to replace it after 3 to 4 years. Okay, but for a lithium ion, the lifespan is very much high. Now, coming towards the eco-friendliness, are they eco-friendly or no? Lithium ion is generally, yes, it is generally regarded as a, eco-friendly, but these are not. Okay, because and now another thing is there, the cost factor. So, as you can clearly see, the lithium ion is very costly in comparison to all these. Also, you can clearly relate to the lead acid base. Okay, so this is the classification of the battery technology. Now, after this, we will move on to towards the another topic which we known as application of the battery, or you can say the optimal sizing and sighting. Optimal sizing and optimal sizing and sighting of ES energy storage. Okay. So actually, optimal sizing, what it does means. It says like, for example, this is any network, electrical network. Okay. There will be energy which will be generated which will be coming from the conventional based sources. Like for example, let's say this is an IEEE 33 bus system. Okay. So IEEE 33 bus system, what it will be? It will be something like this. These are the buses. You know, these are another buses. This is from 19 to 22. This is 1, 2, 3, and this will be 25. These are the bus numbers. You would have heard about it. All, and this is 23, 24. So the main task here is this, in this topic is, where do we place our energy system so that the losses get reduced. Okay, losses gets reduced, variation, voltage variation also get reduced. So this is known as optimal sizing and sighting of any ESS. So there are various, methods to it. First method is known as analytical method. Analytical method. Now, what analytical method? It has an advantage that it is very direct. Okay, and its visualization is very high. You can easily visualize. Its visualization is very easy, but accuracy of the result is very low, because we in an analytical methods we try to assume or linearize our equation. Why we try to linearize our equation? Because when we try to cite any energy storage, we have to reduce power. So as you can you have already known that power flow equations are non-linear and very complex. Okay, so these analytical methods cannot be directly applied on them. So first we have to make simple for them. Another is the mathematical optimization approach. Mathematical optimization approach. So these are also somewhat related to analytical method, but they have accuracy is much higher as compared to the analytical methods. एंड दे आर, हाँ एक और चीज है ये, दे आर रोबस्ट फॉर लीनियर प्रॉब्लम्स. Okay, but the thing is that a very, you know, explicit mathematical models which are very complex will be required to solve the problem formulation for optimal sizing and sighting. Another here is this, artificial, or sorry, meta heuristic based, meta heuristic based approach. Actually, this type of approach is generally used nowadays. Generally used nowadays. Why? Because it is easy and simple to implement. Another thing here is that no gradiency, no gradient or calculation is needed, which has, which we need in mathematical problems, mathematical based approach. Another thing is that it, because these are generally based on sometimes some articles, so they have the ability to avoid local optimum. Local optimum. Examples, PSO, Jaya, GA. These are the examples of the meta-heuristic algorithm. Actually, what happens here is PSO और JA जब भी develop करी जाती हैं, they are generally based on a swarm based. ओके, एक तरीके की एल्गोरिथम पहले डेवलप कर ली जाती हैं और उनका टेस्ट कर लिया जाता है कि ये जो है लोकल मिनिमा, इनका जो रिजल्ट्स होते हैं वो काफ़ी एक्यूरेट होते हैं. उसके बाद ये फिर अप्लाई करे जाते हैं हमारे इलेक्ट्रिकल बेस्ड प्रॉब्लम फॉर्मुलेशन पे. तो इसी वजह से ये इजी टू सिंपल टू इम्प्लीमेंट होते हैं और इसमें कोई कैलकुलेशंस नहीं होती, जैसे मैथमेटिकल बेस्ड डेरिवेशन निकालना होता है, बार बार उसका मैक्सिमम मिनिमा निकालना होता है. और क्योंकि स्वाम बेस्ड होती हैं ये, तो ये आसानी से लोकल ऑप्टिमा को हम इसमें रिड्यूस करा सकते हैं. बट द प्रॉब्लम हियर इज दिस कि ये जो है इनिशियल जो गैस लेते हैं वो बिल्कुल रैंडम लेते हैं. ठीक है, रैंडमनेस इंट्रोड्यूस करा के लिया जाता है. ठीक है, इसमें अगर हमें कुछ पता भी नहीं किसी सिस्टम के बारे में, तो इनिशियल रैंडम गैस लेते हैं, उसको फिर हर इटरेशन में बार बार चेक कर करके हम जो है सॉल्यूशन पे पहुंचते हैं. So that's why we can say their randomness is very high. Okay. और एक और चीज है ये, कभी कभी कुछ अगर मान लो हम खाली पीएसओ लगा देते हैं, जया लगा देते हैं सिंपली खाली एक टाइम पे एक एल्गोरिथम, तो दे हैव द टेंडेंसी सम टाइम दे कैन आल्सो ट्रैप इन अ लोकल ऑप्टिमा. तो फिर हम क्या करते हैं, इसका हाइब्रिडाइजेशन करते हैं, पीएसओ के साथ ऐसे एल्गोरिथम लगाते हैं जो लोकल ऑप्टिमा में ट्रैप ना हो. लाइक लोकल सर्च बेस्ड एलएसए एक एल्गोरिथम है, दोनों को मिला देते हैं, जया प्लस एलएसए को मिला सकते हैं. तो इससे क्या होता है कि जो इसकी डिसएडवांटेजेस हैं उसको हम रिमूव कर सकते हैं. बाकी अदर प्रॉब्लम ऑप्टिमाइजेशन अप्रोच मेथड्स में ये नहीं किया जा सकता. ओके, तो दिस इज basic how we should apply anything. So now coming to a general ESS allocation algorithm. What does it? What it is here? Okay. तो क्या करते हैं, पहले हम आइडेंटिफाई करते हैं. फर्स्ट क्या अप्रोच पहला है, आइडेंटिफाई. What we have to identify the application to be served, और ESS और एप्लीकेशन और सपोर्ट, सर्व्ड और सपोर्ट क्या प्रोवाइड कर रहा है ESS. एक्टिव पावर क्या सपोर्ट, लाइक पावर रिड्यूस कर रहा है, रिडक्शन ऑफ पावर लॉस के लिए हमें लगाना है, या फ्रीक्वेंसी रेगुलेशन के लिए हमें लगाना है. ठीक है, या फिर हमको वोल्टेज वेरिएशन के लिए लगाना है, या इन सभी चीजों के लिए लगाना है. तो सबसे पहले हमको क्या करना है, ऑब्जेक्टिव हमको फॉर्मुलेट करना है. ठीक है, फिर उसके बाद सेकंड स्टेप में हम क्या करेंगे इसके अंदर, किस नेटवर्क पे लगाना है, नेटवर्क इंफॉर्मेशन विल बी गिवन, किसको दी जाएगी, टू द एल्गोरिथम। ओके, और अगर हमें कॉस्ट बेस भी कुछ करना है, इसका मतलब कि कॉस्ट एनालिसिस भी इसके अंदर कर सकते हैं हम, कॉस्ट एनालिसिस भी कर सकते हैं। तो जो भी पैरामीटर्स होते हैं, कॉस्ट पैरामीटर्स, वो भी हम इनपुट करेंगे इसमें एल्गोरिथम। और यस, फिर उसके बाद हम ये देखेंगे कि आउटपुट हमें क्या चाहिए, ये अचीव क्या करें। तो हमको वो क्या क्या चीज करवाना है, लेट्स से ऑप्टिमल ऑपरेशन, ऑप्टिमल ऑपरेशन which ESS has to serve। ओके, और इसके बाद हम क्या करेंगे, इसमें कोई भी कंस्ट्रेंट्स होते हैं, ठीक है, क्योंकि रियल में जो भी रियल प्रैक्टिकल नेटवर्क होता है उसके कंस्ट्रेंट्स होते हैं, वो हमको इसमें इम्प्लीमेंट कराना होंगे। कि लाइक फॉर एग्जांपल, लाइक से हम जो है 33 बस सिस्टम पे हम लगा रहे हैं कोई ESS, ठीक है, तो हमारे पास नंबर ऑफ कैंडिडेट लोकेशन कितनी होंगी। तो देखिए, हम सोर्स पे तो लगा नहीं सकते, 1 पे नहीं लगा सकते, तो हमारे पास कैंडिडेट लोकेशन होंगी 32 कैंडिडेट लोकेशन, इन पे हम लगा सकते हैं। ओके, और कुछ जो भी कंस्ट्रेंट हम ऐड करना चाहते हैं वो भी हम कर सकते हैं। ओके, फिर हम क्या कहेंगे कि जो ESS के साइज हैं, फ्रॉम वेयर हाउ मच इट शुड वेरी, लाइक फ्रॉम 0 टू ESS size to let's say S max, S min to S max. This is more generalized thing. From S min to S max. This is how we should apply the constraint. Then after that, we will be using power flow constraint. Power flow constraint. Power flow constraints, like another is the, these are known as the lower and upper bound. S minimum in an algorithmic term is known as lower bound. This is known as upper bound. Okay, and this is always implemented on the, where it should be implemented, it should be implemented on the decision variable. Now, here in this term, what is the decision variable actually? Here, as I have said here, what we have to do here, we have to size and cite. So the decision variable will be the size and the location. These will vary. Other thing will remain constant or can be used as a constraint. Okay, now after this, what happens here is this, we actually choose which type of optimization method, which type of optimization method we will be using. Like for example, let's say we are using meta heuristic, or we are using mathematical based, or we are using analytical based, any methods we are using, then we will implement that algorithm here after going through all these steps. So what will be here is this, let's say we will minimize that problem. Okay, so we will say that minimize EXC. So here it is, what is X? X is the location and C is the size. So this type of, this is known as, we will formulate an objective function and implement that optimization method on this. Okay, and these equations can be linear or non-linear, but in generally they are non-linear. And after implementing the optimization method, in the finally, what we will do here, we will validate the result कि जो रिजल्ट्स आए हैं वो प्रैक्टिकली पॉसिबल हैं कि मतलब उस पर लगाए जा सकते हैं if we validate the result, what will be the result? Size and the location of ESS. और अगर ये सही होते हैं तो हम we will print these results. Okay, we will finalize these results कि इस साइज के इस लोकेशन पे हम ESS लगाएं. Okay. Now coming to the parameters. Now, what type of parameters can be optimized? So there are two types, multiple types. Like one is technical parameter, which is reduction in power loss, which I have just told you. Reduction in power loss. Another is load demand curtailment. Reduce the load demand curtailment. Or also power flow constraint. These are some of the technical parameters. Another is the economic parameters. What are they? Like optimizing the cost by implementing ES by sizing and citing the ESS, like minimization of investment or replacement cost. Okay. Another is O&M costs, which are known as operation and maintenance costs. These are some of the objectives or technical parameters which we can use to size and cite the ESS. And other are the environmental factors, environmental parameters we should look after, like emission levels, how much emission level has been reduced by by integrating ESS. Also checking the resiliency of the grid after integrating these energy storages. And also another is battery disposal and recycling. These are some of the essential parameters which should be taken under consideration while optimal sizing and citing the ESS. Okay. So now coming toward the another thing here, let's say how the ESS can be integrated. Okay. So first of all, there are several assumptions, like how the energy storage, ESS energy can be stored. So at any time t, energy in an ESS, let's say ET plus 1 will be equal to, for ith storage, EIT minus del T P discharge of ith storage at time t divided by eta minus P charging of ith storage at any time t multiplied by eta. This is the equation which tells energy stored at any time t in ESS. Now, here in this is the energy storage at time t, okay, and P DCHI. What it is? It is discharge power at any time t for ith ESS. Now, in order to avoid, because क्या करते हैं हम कि डिस्चार्जिंग और चार्जिंग एक ही टाइम पर ना हो। रियली इन प्रैक्टिकल सिनारियो वी कैन नॉट, मतलब कि जिस टाइम डिस्चार्ज हो रहा हो तो उस टाइम चार्ज नहीं होता है ना। तो दैट्स व्हाई वी विल असाइन अ पैरामीटर, assign a constraint in it which say u dchi plus uchi will always less than 1। तो जब हम इसको एल्गोरिथम में इम्प्लीमेंट करेंगे तो ये कंस्ट्रेंट हम लगा देंगे। इससे क्या आएगा, दो प्रैक्टिकल रिजल्ट्स निकल के आएंगे। अगर हमने इस टाइम, अगर हमने ये कंस्ट्रेंट नहीं लगाया तो जो रिजल्ट्स होते हैं इट मे और मे नॉट बी प्रैक्टिकली फीजिबल। तो इसका क्या मतलब होगा, अगर किसी टाइम पे यू चार्जिंग 0 हुआ तो ये 1 हो जाएगा, and it can only take values 0 or 1। If it is 1, it will become 0। This is how it is being done। Okay, now what happens here is this। now I have told you about the objective। क्या ऑब्जेक्टिव रहेगा, कैसे हम बनाएंगे। तो ऑब्जेक्टिव क्या होता है हमारा, जनरली मिनिमाइजेशन करना होता है। लेट्स से हमारा क्या है, पावर रेटिंग, पावर रेटिंग कॉस्ट का मिनिमाइजेशन है। प्लस हमारा ऑब्जेक्टिव ये है कि एनर्जी रेटिंग भी मिनिमाइज हो जाए, और हमारा ऑब्जेक्टिव ये है कि ऑपरेशन एंड मेंटेनेंस कॉस्ट भी मिनिमाइज हो जाए, और ग्रिड से जो हम एनर्जी ले रहे हैं, ग्रिड इनपुट, वो ऑल्सो मिनिमाइज हो जाए। तो इस तरीके से हम एक ऑब्जेक्टिव फंक्शन ड्रॉ करेंगे कहीं पे भी। ओके, जब भी हम कोई फॉर्मुलेशन करेंगे, कुछ भी करेंगे इसमें। ओके, सो नाउ अनदर थिंग इज कि पावर लॉस रिडक्शन कैसे हम, पावर लॉस रिडक्शन फॉर्मूला कैसे हम लगाएं, कैसे हम पता करेंगे कि पावर लॉस रिडक्शन फॉर्मूला क्या होता है। तो हमने ये कहा है ना, ऑब्जेक्टिव हमें लगाने होंगे कि पावर लॉस क्या करना है, एक्टिव पावर लॉस, रिएक्टिव पावर। तो पावर लॉस दो तरह के होते हैं, एक्टिव पावर लॉस रिडक्शन और रिएक्टिव पावर लॉस। तो एक्टिव पावर लॉस रिडक्शन इसको हम कहते हैं APR, एक्टिव पावर लॉस रिडक्शन। इट इज PIJ स्क्वायर प्लस QIJ स्क्वायर इंटू RIJ डिवाइडेड बाई V स्क्वायर NO। ठीक है, और QPR विल बी इक्वल टू PIJ स्क्वायर प्लस Q स्क्वायर IJ XIJ डिवाइडेड बाई V स्क्वायर NO। तो ये क्या बताता है, ये फॉर्मूला है पावर लॉस का। जब हम एल्गोरिथम में ऑब्जेक्टिव सेट करेंगे तो हम ये बताएंगे कि हमको ये ऑब्जेक्टिव बनाना है और QPR इसको रिड्यूस करना। ओके, दीज आर द थिंग्स। नाउ अनदर थिंग हियर इज दिस, आई थिंक प्रॉब्लम फॉर्मुलेशन में हमने इसको भी कंसीडर कर लिया है, इसको भी कर लिया है। ओके, so now we will see about what left here in this lecture which we should cover. After that I will solve the questions over here. Okay, so next thing is, okay, now after this we will move on toward the lithium ion battery, lithium ion battery, because these are widely used batteries nowadays। They are used in laptops, mobiles, and generally also they are has been integrated in the electric cars also। Okay, why they has been they are being widely used, I have already told, they have higher energy density, they have higher efficiency, and economically friendly in comparison to other battery technologies which are available। but it has a downside, which is they are very costly. Instead of that, they are very costly. Manufacturers are using them in their models. So this is like, okay, what are their advantages? I will write it down here, some of the advantages. They have negligible discharge rate. Okay, self sorry, self discharge, self discharge. So, okay, high density. This is one of the advantage of them, and commercially they are available in any size. सबसे बड़ी बात ये है कि किसी भी साइज में they are available. Okay, and they are also in the light in weight, and have high potential difference, almost around 4 volt nominal. Nominal voltage difference between them is 4 volt, and also light in weight. So these are some of the advantages of a lithium-ion battery. Okay, but they have also some, for every good thing there is a bad thing. So they have also some of the disadvantages. They are very prone to overcharge and discharge. देखा होगा कि जो मोबाइल के मैन्युफैक्चरर्स होते हैं वो क्या कहते हैं कि आप अपने मोबाइल की बैटरी को डोंट ओवरचार्ज इट. ओके, और nowadays they are also saying don't charge it beyond 80%. बिकॉज क्या होता है कि 80% से ज़्यादा 80 सबसे ज़्यादा स्ट्रेस जो है बैटरी को जब वो 80 से 100 जाती है चार्जिंग में उस टाइम आता है. ड्यू टू दिस 20% the performance goes down very rapidly. Okay, so that's why generally manufacturers कहते हैं कि आप अपनी बैटरी को 80% के अराउंड चार्ज करें. उससे ज़्यादा बहुत इमरजेंसी वो है तो तभी चार्ज करें, अदरवाइज चार्ज अप टू 80%. इससे क्या होगा, बैटरी पे जो स्ट्रेसेस हैं वो रिड्यूस हो जाते हैं और आपकी लाइफ ऑफ द बैटरी विल इंक्रीज. ओके, इससे फिर क्या होता है, एजिंग एंड डिग्रेडेशन इफेक्ट लिथियम आयन बैटरी में बहुत ज्यादा हो अगर हम उसको सही तरीके से मेंटेन और मॉनिटर ना करें. तो इन टोटल वी कैन से दैट इट रिक्वायर्स अ लॉट ऑफ मॉनिटरिंग एंड प्रोटेक्शन. ओके, जितना रफ हम अगर लेड एसिड बैटरी को यूज करते हैं उतना रफ हम लिथियम आयन को यूज नहीं कर सकते. अनदर व्हिच इज वेरी, इट इज नॉट चीप yet. अभी तक ना, टिल डेट इट इज नॉट अ वेरी चीप थिंग कि आप अगर मान लो मैं चाहूँ कि अपने इन्वर्टर में लिथियम आयन बैटरी बेस्ड इन्वर्टर बैटरी लगा लो तो इट विल कॉस्ट लैक्स ऑफ रुपीज. वो लेड एसिड वाली ही सही रहेगी. ठीक है. नाउ अनदर टॉपिक हियर इज दिस, जैसे मैंने बताया अभी प्रोटेक्शन और मॉनिटरिंग चाहिए. तो हर बैटरी सिस्टम को जो भी लगे होते हैं एनर्जी स्टोरेज डिवाइसेस में, दे रिक्वायर अ बैटरी मैनेजमेंट सिस्टम. बैटरी मैनेजमेंट सिस्टम एक्चुअली. ओके, एक सेकेंड. Just a second. Okay. ठीक है. तो why battery management system is required? Why do we need? It reduces the risk of aging, actually प्री एजिंग। एजिंग तो होनी है बैटरी की, बट प्री मैच्योरली ना हो जाए। प्री मैच्योर एजिंग और एनी डिग्रेडेशन, कि मतलब उसको चलना था 8-9 साल, लेकिन 4 साल बाद ही पावर जो है उतनी नहीं मिल पा रही जितनी हमको बताई गई है। ठीक है। और अनोदर थिंग इज दैट कि ऑप्टिमल यूज हो। ठीक है, ऑप्टिमल यूसेज ऑफ एनर्जी। जब जरूरत हो तभी जो है बैटरी के अंदर से पावर आनी चाहिए। ठीक है। और इसी वजह से क्या होता है, बैटरी मैनेजमेंट सिस्टम इज नोन एज द बैकबोन ऑफ ईएसएस। इसी वजह से इसको कहते हैं बीएसएस को बैकबोन ऑफ। इससे क्या होता है, इफिशिएंसी इंक्रीज हो जाती है बैटरी मैनेजमेंट सिस्टम से, क्योंकि इट इज व्हाट इट क्या करता है, ये काफी इंटेलिजेंटली बैटरी को चार्ज और डिस्चार्ज करता है। ठीक है, तो इससे एफिशिएंसी बढ़ती है और रिलायबिलिटी ऑफ द सिस्टम इंक्रीज कर जाती है, एंड कॉस्ट ऑफ द सिस्टम बी, और वी कैन से एक्सपेंडिचर ऑल्सो रिड्यूसेस। क्यों? क्योंकि मान लीजिए बैटरी मैनेजमेंट सिस्टम की वजह से एक बैटरी 10 to 15 ईयर्स चलेगी, और अगर बैटरी मैनेजमेंट सिस्टम नहीं लगाते हम तो 8 to 9 ईयर्स चलती। तो 8-9 साल के बाद पूरी स्टोरेज को हमें हटाना, दोबारा इंस्टॉल करना पड़ता है। इससे जो है हमारा एक्सपेंडिचर बच जाता है। तो एक्चुअली बैटरी मैनेजमेंट सर्किट मैनेजमेंट करता क्या है? तो व्हाट इट डज हियर इज इट मॉनिटर्स द करंट, voltages and temperature of each cell। जो भी बैटरी के अंदर बहुत सारे सेल्स होते हैं, हर सेल का टेम्परेचर, वोल्टेज, करंट मॉनिटर करता है। ठीक है। और स्टेट ऑफ चार्ज एंड स्टेट ऑफ हेल्थ। ठीक है, स्टेट ऑफ चार्ज और स्टेट ऑफ हेल्थ ये मॉनिटर कर बाय यूजिंग, देयर आर डिफरेंट टेक्निक्स नाउअडेज एक्चुअली, आर्टिफिशियल और मशीन लर्निंग बेस्ड मॉडल्स आर देयर which are much better than conventional and or analytical methods to determine the SOC and SOH। तो आजकल क्या होता है, मशीन लर्निंग बेस्ड मॉडल्स बनाए जाते हैं जिसके बेस पे ये SOC और SOH एस्टिमेट करता है। और SOC का एस्टिमेशन इज वेरी इंपॉर्टेंट बिकॉज SOC will tells a battery management controller when to stop and when to start the charging। ओके, तो क्या करते हैं इसमें मशीन लर्निंग बेस्ड मॉडल्स क्या होते हैं, एक क्या होता है कि पहले एक डेटा लिया जाता है बैटरी का, जिसमें एज मैनी एज इनपुट पैरामीटर्स वी कैन टेक वी, आई, टेम्परेचर। ठीक है, तो these data will be there, okay, and these data will be around lakhs of thousands of data। Okay, after that, based on that data, a machine learning model will be developed, and that machine learning model will forecast, will be again implemented on that battery to check whether the model is being working correctly or not, and that working correctly, then this machine learning model will be used in the battery management system। Okay, so actually this is the this is measurement of current, voltages and temperature, After this, what it will be here is this estimation of SOH and SOC in this whole. Then after that, computation of energy और और energy limits, हाँ कितनी energy दे सकता है, power limit will be calculated और इस डेटा को हम स्टोर कर लेते हैं, जो कि डेटा हमें, जो मैंने ये बताया था, मशीन लर्निंग मॉडल डेवलप करने के लिए यूज होता है. ओके yes, now I will talk to you about some of just SOC estimation technique. I just talked briefly about it. So what I said here, there are conventional methods. Conventional methods. इसका क्या है? These are easy to implement. Easy to implement. Low accuracy. Low accuracy होती है estimation की. और आसानी से जो है एक रिसर्चर और एनी स्टूडेंट कैन इजीली अंडरस्टैंड दिस. बट द थिंग एंड दीज आर जनरली ओपन सर्किट वोल्टेज एक मेथड है, कन्वेंशनल मेथड है. एक है कूलम काउंटिंग, एक मेथड है. एक मेथड है जिसमें इलेक्ट्रोकेमिकल इम्पीडेंस निकाला जाता है, जिससे हम करते हैं. ओके, दीज आर कन्वेंशनल बेस्ड मेथड्स. अनदर एक मेथड है, अनदर टाइप ऑफ मेथड इज फिल्टर बेस्ड मेथड. दिस इज अडेप्टिव फिल्टर बेस्ड मेथड. इसमें कालमान फिल्टर इज वन ऑफ द रिकॉग्नाइज्ड मेथड. कालमान फिल्टर. फिर एक आता है एक्सटेंडेड कालमान फिल्टर मेथड होता है. ओके, अब इसमें क्या होता है, इन मेथड्स की एक्यूरेसी इन कंपैरिजन टू कन्वेंशनल मेथड्स काफी हाई होती है. बट द प्रॉब्लम हियर इज दैट क्योंकि कालमान फिल्टर और ये एक्सटेंडेड कालमान फिल्टर दे आर हाईली कॉम्प्लेक्स मेथड. इसमें जो इक्वेशंस होती हैं दे आर हाईली कॉम्प्लेक्स, not easy to implement. Okay, this is one of the major drawback of this method. Now comes the learning algorithm method. Learning algorithm method. They are generally independent methods like neural network. We can use fuzzy logic based. We can also use genetic algorithm based. Also we can use other methods also. Accuracy is very high. And they are also, but the thing is that for training these methods, they require a lot of, large amount of data is required. Large amount of data, जो कि मैंने अभी बताया कि lakhs of thousands of data मिलता है, उसके बेस पे हमको जो है एक मॉडल डेवलप करते हैं. उस डेटा की वजह से हमें लार्ज मेमोरी यूनिट्स भी चाहिए. नॉर्मल कंप्यूटर में हम इसका कंप्यूटेशन नहीं कर सकते. फिर इसी वजह से कॉस्टली प्रोसेसिंग यूनिट्स होते हैं. जो नॉर्मल कंप्यूटर्स होते हैं उन पे हम मशीन लर्निंग बेस्ड मॉडल्स नहीं चला सकते, तो इसलिए उनके लिए एक डेडिकेटेड बेस्ड कंप्यूटर सिस्टम्स बनते हैं. एंड वन ऑफ द मेजर disadvantage of this, it is very time consuming. It is accurate, but in initial phase it is very time consuming based method. Okay, now comes another method which is the hybrid of these methods, which we known as hybrid. Actually we can say advanced algorithm. They are generally hybrid. What do you mean by hybrid? कि हम क्या करेंगे, इनमें से कोई एक मेथड लेंगे और उसको हम किसी दूसरे मेथड के साथ हाइब्रिड करा के मिला के हम एक नई एल्गोरिथम बना लेंगे। ठीक है, लाइक न्यूरल फजी बेस। क्या होता है इससे, जो इनकी आपस की जो डिसएडवांटेजेस होती हैं, डिसएडवांटेजेस वो रिमूव कर दी जाती है और दोनों एल्गोरिथम्स की एडवांटेजेस को क्या कर दिया जाता है, कंसीडर कर लिया जाता है। तो इससे क्या होता है, हमारा जो भी हमारी डिसएडवांटेजेस होती हैं उसको रिमूव कर देते हैं और एस्टिमेशन ऑफ एसओसी इज वेरी गुड। ओके, okay, now after this I will show you a schematic of an IC. Actually, just let me see. Okay. So after this is all about SOC estimation, battery management system क्या काम करता है. This is an overview of it. Okay, इस तरीके से हम बैटरी मैनेजमेंट की क्या एडवांटेजेस हैं वो करेंगे. Now after this we will solve the questions. Okay, because it is our main objective here. This is all just a recap what you have learned over a weekend. So now coming towards the question. So the first question will be what it is. Now the first question here is this. John A. Now you have to answer in the chat. Okay. John A. developed in flywheel energy storage in which year he developed. This is I have talked about in my lecture. So you must answer in the chat. Okay. Now people start leaving when I ask them answer. No problem. I will answer it. If someone देखो इसका आंसर क्या है. I have talked about in my lecture that in 1883 John A has developed the flywheel storage. ठीक है. Next question is which of the following first is I will write black start service. Second is reduce renewable energy curtailment. Okay. Third is capacity investment deferral. Fourth is frequency regulation and flexible ramping. Okay. तो क्या करना है इसमें, which of the following depicts the need of ESS in power grid. Answer in the chat, then I will explain. So the question here, second question here is this. Which of the following depicts the need of ESS in a power grid system operation? First one is black start services. Second is reduce renewable energy curtailment. Third is the capacity investment deferral. Fourth is the frequency regulation and flexible run. इसमें से कौन सी ऑप्शन ये बताते हैं कि हमको ESS चाहिए, इस जरूरत है. दिस इज क्वाइट क्लियर कि ईएसएस की नीड जो है क्यों है, इज यूज टू ब्लैक स्टार सर्विस। मीन्स जब हमें आउटेजेस होते हैं, जो कुछ सर्विसेज स्टार्ट करनी होती है, उस टाइम को हम जो है ईएसएस का नीड रहता है। ओके, ईएसएस का नीड कब रहता है? जब फ्रीक्वेंसी रेगुलेशन, यानी हमें को फ्रीक्वेंसी रेगुलेट करनी है और फ्लेक्सिबल रैंपिंग का, जब जो है हमको पीक डिमांड का करना होता है। सेकेंड ऑप्शन टेल्स यू अबाउट रिड्यूस एनर्जी रिन्यूएबल एनर्जी कर्टेलमेंट, कि रिन्यूएबल एनर्जी कर्टेलमेंट को रिड्यूस करता है, नहीं, ये तो गलत ही है। कैपेसिटी इन्वेस्टमेंट डिफरेंस, दिस इज रॉन्ग। तो फर्स्ट एंड द फोर्थ इज द करेक्ट आंसर। नाउ नेक्स्ट क्वेश्चन इज थर्ड वन। According to storage deployment statistics released by US Department of Energy in 2017, which of the following is correct regarding India? India के regarding which of the following statements are correct? First statement is pumped hydro storage has the highest share of total storage. Okay. Second is thermal storage जो है, thermal storage is greater than electrochemical and electromechanical storage. Answer this in the chat. देखो ये वाला मैंने टर्म जो है लेक्चर में अभी बताया है कि इंडिया में डिप्लॉयमेंट क्या स्टैटिस्टिक्स है in 2017. I think I have shared it over here. Yes, this is. So the answer to this here is what it is. क्या है कि पम्प स्टोरेज सबसे ज्यादा है, जैसे 6.8, ये क्या है? पम्प स्टोरेज है। एंड 0.2 क्या है? थर्मल इन 2017 एज पर यूएस डिपार्टमेंट ऑफ एनर्जी। तो ऑप्शन 1 एंड ऑप्शन 2 बोथ आर करेक्ट। ओके, now next question 4 is which of the following is wrong? First is pumped hydro. It is a hybrid energy storage system. Okay. Second is lead acid. It is electromechanical ESS. Third is biofuel. It is chemical ESS. Fourth is battery and flywheel. It is hybrid ESS. So इसके आंसर चैट में बताओ. I will wait for few seconds, then we'll answer. B. Okay. नहीं, देखो इसमें क्या है. Pumped hydro. It is a not a hybrid energy storage system. It is a mechanical system. So that's why this is wrong. Now lead acid. It is electrochemical ESS. नहीं, ये क्या है? ये एक electrochemical, not mechanical. Okay. ये biofuel. It is of course it is right. Biofuel is chemical ESS. Battery and flywheel. It is a hybrid. Means it is chemical plus mechanical. और ये pumped hydro क्या है? ये mechanical. ये नहीं. So the correct answer will be 1 and 2. These statements are wrong. ये दोनों statement क्या है? गलत. Okay. So next question. Which storage technology has a very good usable capacity? First, flywheel. B, lithium ion. C, supercapacitor. And D, lead. तो इसका आंसर मुझे चैट में बताओ कि किस टेक्नोलॉजी की गुड यूजेबल कैपेसिटी है. मतलब क्या बताना है इसमें कि ज्यादा परसेंटेज ऑफ कैपेसिटी किसकी यूज करी जा सकती है, एफिशिएंसी जिसको कहते हैं. आई विल वेट फॉर अ सेकंड. ओके, आंसर इज सी. यस, लिथियम आयन की एफिशिएंसी भी बहुत हाई होती है, 95% होती है. डेंसिटी भी इसकी ज्यादा होती है और एनर्जी डेंसिटी पावर डेंसिटी दोनों ज्यादा होती है. So this is the correct answer. Lithium ion is the correct answer. Okay. This is the sixth question. What is the storage capacity of Tehri pumped storage प्लांट? इसकी क्या कैपेसिटी? ए 750 मेगावाट, बी 350 मेगावाट, सी 950 मेगावाट एंड डी 1000 मेगावाट. When proposed, जब इसको प्रपोज किया गया था तो इसकी कैपेसिटी कितनी थी? तो राइट आंसर इन द चैट. आई विल वेट फॉर अ सेकंड. So the correct answer here is this 1000 megawatt when it was proposed. It is this. Okay. Now, seventh is energy storage tender activity increased in 2021 by how much percentage? A 14%, B 41%, C 45%, D 54%. Okay. So yes, yes. So answer is 41%. What happens here is this: in Indians, the Indian to actually what happened here is government to increase the Indian energy storage capability. What happened here is this: in coordination with other companies, it increases the tender activity by 41%, and around 7700 megawatt hour of ES projects were tendered. Okay. So now eighth question is battery management system does first regulate the frequency of the grid, protect the battery health, and third, none of these. Answer in a chat box. So what it does protect the battery health by limiting the overcharge and the discharge rate. Okay, this is how it does. Next, ninth question is: suppose the objective of any optimization problem is convex, then which of the following is true regarding the optimization problem? Okay. First is non-linear constraints always results in non-convex problem. Second, linear constraints always results in a convex optimization problem. Third, linear constraints may result in a non-convex optimization problem. Fourth, non-linear constraints may result in a non-convex optimization problem. So write down which of these are true regarding the optimization problem. There may be sentences which are more than one, which are correct. More than one can be correct in this. So in this, the first option says, actually what happens here in this, a a convex optimization problem needs, actually it needs a convex objective function and also convex constraints. So always constraint linear constraint always result in the convex optimization problem. This is the thing. So non-linear constraint always result in the non-convex optimization problem. This is wrong. Because non-linear constraint may or may not result, actually non-linear constraint may result in a non-convex optimization problem depending upon their convexity. So not always is not correct. Okay. Linear constraint always result in a convex optimization problem. Yes, it is correct. This is correct. Linear constraints may result in a non-convex optimization problem. No. Linear always results in a convex optimization problem. Non-linear constraints may result in a non-convex optimization problem. It can be happening. So, कौन से सही हुआ? Second सही हुआ and fourth सही हुआ. So we can say that second and fourth are the correct option regarding the optimization problem. Nine. Which is not an active cell balancing method. First is cell to cell. B. Overcharge. C. Cell bypass. D. Pack to pack. You must have gone through this method in your lectures. So write down the correct answer. Yes. So the correct answer here is this. Overcharge method is not an active cell balancing method. It is a passive cell balancing method. Okay. The next question is 10. Why BMS is required? First, to increase the efficiency of battery pack. Second, optimal usage of energy. 3. Reduce the risk of prematurity in a battery. 4th, none of these. So, what are the options which are correct according to the statement why battery management system is required? It is quite clear. It is done to increase the efficiency of the battery pack. It is also done, yes, yes, 1, 2, 3, yes, it is correct. Optimal usage of energy. Third is reduces the risk of prematurity of the battery pack. Okay, so 1, 2, 3 are correct options. That's why we call battery management system as the backbone of the all battery pack. Okay, so now another question here is, I will write it down. Consider a grid connected battery energy storage system with a nominal capacity of 100 megawatt hour and depth of discharge of 80%. If BSS is cycled once per day, यानी एक दिन में एक साइकिल हो रही, what is the maximum usable energy that can be delivered to grid per day? Okay, try to solve. I will give you a minute. If not, then I will solve it. Okay. It is actually very, easy question. You guys can give an answer to this. Actually, solution to this is usable energy. Usable energy is always equal to nominal capacity into depth of discharge. And actually, depth of discharge, it indicates what the percentage of the battery capacity that can be used. ठीक है, तो यहाँ से हम यूजेबल एनर्जी कैसे निकाल सकते हैं? नॉमिनल कैपेसिटी कितनी दी गई है? 100 मेगावाट आवर, 100 इनटू डेप्थ ऑफ डिस्चार्ज कितना? 80%. तो 80% इस्तेमाल करी जा सकती है, So around 80 megawatt hour usable energy और जो maximum usable energy होती है, maximum usable energy is equal to the energy that can be delivered to grid per day. So in this case, it will be equal to 80 megawatt hour. So this is the answer. Okay. Now, another question number 2. A pumped hydro storage with a height difference 200 meters and a flow rate of 500 cubic meter per second. This storage has an efficiency of 85%. Calculate the theoretical power output. Take G is equal to 9.81 meter per second square. Okay. So I will wait for a second, for a minute. If you can solve it, write the answer in the chat box. Otherwise, I will solve. Okay. So we know that in a pumped storage, theoretical power output of a pumped hydro storage is P is equal to rho into G into H into Q into efficiency. Rho here is density of water. G, we all know, 9.81 meter per second square, acceleration due to gravity. H, it is given in the question, it is a pumped storage with a height difference of 200 meters. And Q is the flow rate. It is meter cube per second, and it is given here in this 500. And eta is the efficiency, which is 85. We can say 0.8. If we put all these in the equation, P rho. Now, density of the water is in kilogram per meter cube is 1000 into the 9.81 into H 200 into 500 into efficiency 0.85. If you calculate it, it will come out to be 832.350.000 watt, and it will be equal to 832 megawatt. Here, 1000 is the density of the water. Okay, in kilogram per meter cube. Now, now, next question here is 30. Which of the following is a disadvantage of flywheel storage? First, high energy density, longer lifespan. Third is high self discharge. Fourth is fast response time. Okay, so answer me in the chat box. Actually, the disadvantage of the flywheel storage is the higher self discharge rate. Okay, this is one of the reason of this. Okay, now another question. The last question over here is which of the following factors is most critical in determining the lifespan of lithium ion battery? First, depth of discharge. B, ambient temperature. C, charging and discharging rate. And D, first A and B, both. So, which of the following factor is most critical in determining the lifespan of a lithium-ion battery? There will be more than one correct answer. Okay, I will wait for a minute and you can write down the answer in the chat. So, actually, all these options are, most critical for determining the depth of, the lifespan of a lithium-ion battery. Actually, If depth of discharge is high, the lifespan will reduce. And you know that if battery is operated in extreme temperature other than ambient temperature, lifespan will reduce. So this is also most critical aspect. This is also most critical. And you also know that high charging and discharging rates increases the wear and tear. So the correct answer is A, B, C. All these are the correct answer. So with this, the today's session has been concluded, and I hope you have enjoyed this session. And I have tried to clear as many as things you have studied about this. Thank you.